Find the domain and range of the relation graphed to the right. Well, this graph shows a blue vertical line which crosses the x-axis where x equals 3, and it has two arrows, an arrow either end of this line, which indicates that the line continues upwards forever and downwards forever beyond the confines of our graph. Well, let's consider the domain, recalling the domain is the set of all possible x values for this relation, or another way of saying that is all possible inputs that we could input into the relation. Let's consider a few here. What happens when x equals -4? X equals -4, if we draw a dotted line above and below this value on the x-axis, we get no intersection with the curve, which means that we can't input x equals -4 into the relation and get an output that is meaningful out of it. Similarly, for x equals 1, we could do this. Again, there's no intersection with this line. Let's try one more. Let's try x equals 5. For x equals 5, we draw a dotted line. Well, this dotted line doesn't intersect this line either. In fact, the only dotted line that we can draw through any of these points is the dotted line that crosses the x-axis at x equals 3. This might be hard to see, but if I draw a dotted line here, this dotted line is the same as this vertical line, and it crosses, or it doesn't cross this line, but it touches this line at every point. So this means that the x value, x equals 3, is the only valid input for this relation. If we were to project this relation onto the x-axis, the only point we'd get is this point here, x equals 3. All values greater than x equals 3 or less than x equals 3, those aren't valid inputs for this relation. Consequently, our domain consists simply of the point x equals 3. Let's consider the range, remembering that the range is the set of all possible outputs or all possible y values for this relation. Well, if we were to choose any of the points on this y-axis and draw a dotted line to the right and to the left, we would get an intersection with this line, and the associated x value would be x equals 3. In other words, let's choose y equals 2. At y equals 2, if we draw a dotted line to the left and the right, sure enough, we do get an intersection with this line. And these arrows show that this behavior continues for all y values, including those that approach positive infinity and those that approach negative infinity. In other words, this whole entire y-axis is the range. And the way that we show this is that we can draw a line through the y-axis, and we draw an arrow at the top and an arrow at the bottom. And this indicates that the range for this relation is all real. It's the set of all real y values. We'll just write this as all real y. And that's the domain and range.